Okay, 2010 number 2. Um, Radio station plays 40 rock and roll songs during each 4-hour show. Um, Rock and roll, you know, that good music. Yes. Program director at a station needs to know the total amount of airtime for the 40 songs so that he can, so that time can be programmed during the show for news and advertisements. The distribution of lengths of rock and roll songs in minutes is roughly symmetric, with a mean length of 3.9 minutes and standard deviation of 1.1. So the population is symmetric with a mean length 3.9, standard deviation 1.1. Describe the sampling distribution and sample mean length songs for samples of 40 rock and roll songs. So the sampling distribution of the sample mean. Okay, so A. Sample distribution. That's what we call the X bar distribution. Okay, and now when it says describe the distribution, do you remember? Describe the distribution. Socks. Shape, outliers, center, spread. Shape, outliers, center, spread. Okay, well, let's first of all talk about the sampling distribution. Since the population is symmetric and the sample size we're taking is 40, which is definitely more than 30, we know that the sample distribution is going to be approximately normal by the central limit theorem. So sample distribution is approximately normal. Never ever say it is normal. Always approximately normal. In fact, if you say it's normal, you'll only get partially correct instead of essentially correct on this problem or any problem. So it's approximately normal since n is equal to 40 by the central limit theorem, with mean 3.9 and standard deviation 1.1 divided by the square root of 40. Okay, now that takes care of the shape, takes care of the center, takes care of the spread. Okay, are there any outliers? Since there aren't any outliers in the population, it didn't say anyway, there probably aren't any outliers here either. So we're okay just mentioning that. There don't appear to be any outliers, since none mentioned in the population. Okay, so there we took care of each of those. Shape, center, approximately normal, center is the mean, spread, and hours. Okay, so good. By the way, it never ever hurts, and it can only get you points if you do the picture as well. 3.9 standard deviation, 1.1 divided by the square root of 40. Okay, and then B. If a program manager schedules 80 minutes of news and advertisements for the 4-hour show, only 160 minutes are available for music. Approximately, what's the probability that the total amount of time needed to play 40 songs exceeds the airtime? So I want to play 40 songs. What's the probability that it goes over 60 minutes? And at first it's kind of like, oh, how am I going to get this? Because how do I do 160 minutes in 40 songs? And we're talking, I know about an average of 40 songs. It has a mean of 3.9 and standard deviation, but now we're talking 40 songs total. Well, two ways to do this. One way, option one, is to recognize this. If 40 songs, and you don't have to write this down, you just have to think this. 40 songs is over 160 minutes. Then the average, then X bar is over 4 minutes. Right? 160 divided by 40 is 4 minutes per song. So the average song length would be over 4 minutes. These two say the same thing. So really what we're asking then is, what's the probability that X bar is greater than 4? And that's, if I come over to this graph over here, we're really just saying, if this is 4, what's the probability that I'm over here? Well, that's just the probability that Z is greater than 4 minus 3.9 over 11 or 1.1 divided by the square root of 40. And if I do that on my calculator, and at this point, I can actually do normal CDF on the original. 3.9, a big number. Mean, oops, not 3.9. Normal CDF, 4, comma, a big number, comma, 3.9 is the mean, and then the standard deviation is 1.1 divided by the square root of 40. Okay? And so this is what I put in my calculator. This is what you don't write on your papers. 4, a big number, 3.9, 1.1 divided by the square root of 40. And if you do that, you get 28.27%. So the probability that it exceeds 160 minutes is 28.27%. And you're good to go. Now the second option is simply to say, well gosh, 100, what if I just took 40, if I took 40 songs, and I want to know what's the probability that it's over 160 minutes. So what if I looked at a distribution of x plus x plus x 40 times, and I just calculated it that way. And I said, here's the mean is 3.9 times 40. I got 156 and did the standard deviation. Now what do I do? This is a good review. What do I do when I have the standard deviation? Do I just multiply it by 40? No, I have to find the variance. 1.1 squared is 1.21, that's the variance. And I had it 40 times, so I have to add it up 40 times, or times 40. And I get 48.4. And then I take the square root of 48.4 to get the standard deviation back. And I get 6.96. And I want to know what's the probability that x is over 160. And let's see if we get the same answer. That z is greater than 160 minus 156 over 6.96. And if I do that, I'll do second. Normal CDF, 160, a big number, 156, 6.96, and I get 28.27. So I get the same answer, which I got 2. Either way, you're good to go. Okay, there you go.